Welcome to Chapter 10, Part 2. If you've not listened to Chapter 10, Part 1, I do recommend you go back and listen to it now. We're going to be continuing now with our discussion of the selection effect. Now, selection is a major potential threat to internal validity. It occurs when persons in one condition are different in some systematic matter than the persons that are in the other condition. If people decide what condition that they're going to take when they come into a study, it's obviously a risk, but it can happen any number of other ways by virtue of how you create your conditions in the study. For instance, you could decide that you're going to do one of your conditions in the morning and the other condition in the afternoon, and it seems innocuous enough, but you have to take into account that some people genuinely are more alert and more able to follow instructions in the morning, and some persons are more alert and more able to follow instructions in the afternoon. And so there's a real selection effect issue that has been created by virtue of what seems like a completely innocuous decision on when to have the conditions in your study. Therefore, you want to be very careful of that kind of problem. It threatens internal validity because, in the end, you can't be sure that the differences you see in your dependent variable are due to the manipulation of the independent variable or to the participants' differences between the two groups. If there's only two groups, it could be three groups. To deal with the threat of selection, we have a few tools. We can do random assignment and we can do matched groups. And then we'll learn about another tool a little bit later. Random assignment is when we move people randomly into one of the two conditions after they've been named to be part of the study. They've come into the study. Even if the participants are coming to the study one at a time, we can randomly assign them conditions. The idealized image of it, though, is you have a bundle of people that you have somehow acquired either by random selection or by some other sampling method, and that's represented by this collection of human-like looking things over here on the left side of the screen, and they will be randomly being assigned to the two conditions in the study represented by the boxes. And so as we see, and you saw earlier when I used a similar animation, persons randomly being selected, and the differences that might be represented by green persons and pinkish purple persons are being more or less evenly distributed into the two groups, and you don't have a systematic bias in the study, and therefore you don't have the problem of a confound due to selection, due to having different kinds of people in the conditions of the study. Another approach is to use what's called matched groups. Now, matched groups is a process of pre-testing on an important relevant variable and then randomly assigning the neighboring pairs, or it could be triplets or it could be quadruplets of persons if you have four conditions in the study, and randomly assigning them after you have grouped them into these subsets. Now imagine that we're doing a study on an intervention to reduce absences at work. Now, absence is noted to be related to age of an employee, and you want to control for that. That is to say, older employees tend to be absent less. Younger employees, particularly younger employees that have kids, are more likely to be absent more often. And so what you want to try to do is match persons on age to try to have that not be somehow accidentally systematically varying between the two conditions of the study. This is a particularly acute problem if you don't have a large sample size. And so using matched groups can be very, very helpful in that kind of situation. So let's imagine that we've got 10 people that have been brought into this study, and and this is what they look like by unsorted ages. We have people who are a person who's 58, a person who's 31, 20, 22, and so forth. And what we're going to do is we're going to sort them. The 20-year-old is the youngest person in the group, and a 22-year-old is next youngest, 24, 28, and so forth, and all the rest of them. And now we have them in order from at the bottom the youngest aged person to the top the oldest person in the group. Now what we do is we kind of put a box around the pairs. This doesn't have to be literally done this way, but it kind of helps to keep you organized. And what you've done is you've paired up the top two aged persons, the next two aged persons, the next two aged persons, next two aged persons, and the bottom two aged persons, the 20 and the 22-year-old, are paired with each other. They're matched. That's the idea, is the matching occurs right here. They're matched on age. Now, they're not identical in age, though, in an ideal world that might happen, but they're close pairs, and this is a process that more or less minimizes the differences between the individuals. And the next step is to simply randomly assign them to the control or intervention conditions of the study. And so maybe we randomly have the 20-year-old go into the intervention, and the 22-year-old then therefore goes into the control condition. Once the 20-year-old was assigned, then the 22-year-old was going into the other condition. We do the same thing with the 24-year-old and the 28-year-old. And we do that for all of the rest of them. The 31-year-old goes into the control condition, the 35-year-old into the intervention condition. This is all, we're treating it as if it's happening randomly. 43-year-old, 48, and the 58-year-old and the 62-year-old. So we now have randomly put them into the conditions of the study. What we're trying to do is make it so that the average age, and roughly speaking the span of ages, and we have all the age groups represented well, or at least evenly, in the two conditions of the study. And just by visual inspection it looks like that, and we can do a calculation to show it as well. And we see for the control group the average age is 37.2 years old, and for the intervention group it's 37 years old, and well, that's pretty darn good, I think. Matched groups seem like an ideal solution to the problem of making sure our groups are equivalent on relevant variables. And it is. It's great when you've only got one, maybe two variables that you're concerned about. And you can get a hold of those variables. You can actually measure them without tipping people off as to the nature of your study. But once you get past two variables, it gets to be very unwieldy. It's just very difficult to do matching on more than two variables. Doing it on more than one variable is tough, but more than two variables, and wow, you've got to have a lot of participants, and you basically lose almost all the advantages of using this kind of design. In that case, when you have a lot of potential matching variables, you're better off just getting as big a sample size as you can and trusting random assignment. It leads us to thinking in terms of independent groups. When you trust random assignment, you're doing an independent group's design. And this comes in two flavors based upon your book's description. And I have to say, this is a little bit of an unusual treatment that your book takes on this, but I don't think it's an incorrect treatment. I think it's just a little unusual, especially in a book that's targeted at the undergraduate level. The book describes the two flavors as a post-test only design and a pre-test post-test design. Now, post-test only design is the simplest independent group's design. You have two or more conditions in the study, and what you do is random assignment to the conditions. You measure after the manipulation has been applied, and that is to say, the reason this is called a post-test only design is the measurement is post or after the manipulation is done, a post-test. A pre-test post-test design is when the participants are randomly assigned to conditions. Sounds a lot like what we were just doing, but it differs from the post-test only design in that participants are measured on the dependent variable before the manipulation is applied, and then measured again after the manipulation is applied. We gain some confidence by this process that the groups did not differ on the dependent variable prior to the manipulation. This is very, very helpful for ensuring that we don't have any kind of selection bias, a selection effect problem, that the two groups seem similar to each other on what we're trying to measure about them in the first place. So it's good, especially if there's going to be a long time between the entry into the study and the final measurement of the study after a manipulation has been done. It's also good if you think that both conditions are going to have some kind of an effect, and you're particularly interested in how those effects differ. That is, the intervention that makes for one of the conditions you think might decrease the person's response on the dependent variable, and the other manipulation might increase. And if you think that's going on, or if you think they both might increase it, but they're going to increase it differently, you want to be able to really show that well. And this kind of design can really do a great job of showing that. And so it's a really excellent design to use in a lot of situations. Your book gives an excellent description of Carol Dweck's research on how to encourage children to have higher self-esteem, and therefore that self-esteem translate into actual productivity rather than simply feeling good about yourself. Within groups design is another way to handle selection threat to internal validity, and these come also in two flavors: concurrent measures and repeated measures. Now, concurrent measures version is when two stimuli are presented simultaneously. For the dependent variable, the person gives a response to both or shows a preference for one or the other in some way. Remember, we did a presentation in in one of my previous presentations. There was a slide that showed two pictures of Audrey Hepburn, and you had a selection of a preference, or you could indicate a rating of attractiveness about Audrey Hepburn. That is an example of a concurrent measures type of design. Repeated measures designs are those in which each individual in the study is exposed to all the manipulations of the study. You're measured on the dependent variable after each manipulation. Now, this is a very different thing than pre-test, post-test, and we'll touch on that a little bit later. The biggest advantage in within groups design is the elimination of any concerns about selection effects. That's because there's only one group of participants who experience all the conditions offered in the study. There's no need to worry that one group differs from another group on some important variable. Every individual in the study effectively serves as their own control. You don't have to have them matched up to some other person. You don't have to hope that random assignment creates two equal groups for you. This is a tremendous advantage. It also has some statistical power. It makes things go better statistically often, not always, but often. But there are practical problems that come with there's disadvantages within groups design. The practical problems are you need access to the participants longer. You're going to have these people for some period of time for multiple measurements, even to the point of it being several days or even weeks. I one time was in a study that was going to take approximately 3 weeks of me spending a couple of hours sitting in front of a computer terminal doing the same thing over and over again. I do not have that kind of patience, and it did not work for me. And I had to bail out of the study, which was, well, I didn't love doing it, but it was the right thing for me to do. Setup can be very lengthy, and resetting the procedure for the second and third manipulations can take time. Long downtime for participants, and all these things can create the opportunity for confounds to enter into the study. For the participants to do thinking about what's going on in the study that can cause problems. So you have to have ways of distracting participants or having them occupied otherwise, even with tasks that aren't really part of the study, just to kind of keep them from ruminating on what's going on. Participants also can just become tired and bored by doing the same thing over and over again. That's effectively what happened to me in this when I was describing my anecdote from earlier. No longer really engaged, they're no longer paying attention, and they just don't care anymore. And that's really bad for your research. You get into more pernicious and difficult to manage kinds of disadvantages when you start talking about the interference that can happen. But fortunately, we have some fixes for these things, though they are imperfect. You may be starting to get the sense that everything's imperfect in this world. It's a fact. Everything is imperfect. This world is all about trade-offs. Doing research design is all about trade-offs. Interference between conditions is the main thing we have to worry about when we have within groups repeated measures kind of study. Interference can create a confounding variable. They're called order effects in general. What you're saying is that persons can maybe give useful responses in both of the conditions that you have them in the study, but there's an inherent confound in having one condition always appear before the other condition. That is, people get used to it and all that. Well, let's talk about them. It's a confound because you can't know if the differences you see between the conditions are due to the intended manipulation or the order of presentation. You just don't know why you're seeing some difference in your dependent variable. Alternative explanations could be fatigue, people being more fresh and attentive in the early trials, and they're getting kind of tired in the later trials. Could be practice effects. They're getting better at what they're doing, so they're more comfortable and accustomed to the procedure, and therefore are less reactive to the manipulations, or simply just not doing as paying attention as well, or they don't need to pay attention as closely, and they can make mistakes then. So practice effects aren't always benefiting; they're always improving. Sometimes it's hurting scores. To deal with practice, what we mean by practice effects in more detail is once participants have been in one condition, they can't be in the other condition with the same naivete. For instance, imagine that you're teaching people to play a new game, something like Angry Birds, and you want to know, will they learn to play well faster on a tablet or on a phone? Now, once they've learned it on one device, they're not starting from the same point of ignorance for learning it on the other device. This is kind of an obvious case of practice effects. More subtle versions of these are all over the place in your studies if you start to look at them carefully with a critical eye. And it is easy, once you've gotten accustomed to a procedure, to think that practice effects aren't going to be a problem when they really could be. Carryover effects are a variation in which one order means there's contamination from one condition to another, but the other order is not going to have that contamination. That is, presenting condition A before B has a big effect on how B is interpreted by the participant. But having B before A has a very different, and it's not an opposite or contrasting effect compared to the former. They're not, well, balanced or countervailing. They're different. It's kind of like the difference between brushing your teeth before drinking orange juice and drinking orange juice before brushing your teeth. It's a very different experience going each of those two directions, isn't it? That's an example out of your book, which I just loved. Counterbalancing means that you change the order of presentation of stimuli to get some control over order effects, hopefully to remove them entirely. Participants are split into groups, and each group gets a different order of conditions. Now, there's two basic kinds of counterbalancing that can be done: complete and partial. Now, this sounds like that covers everything, and it kind of does, but there's some subtypes of these, as you might imagine. Complete counterbalancing means that all possible orders of conditions are used across all the participants an equal number of times. Basically, you're going to create subgroups of participants, and some groups are going to get the condition A, then followed by B, and some groups are going to get condition B, followed by A. And so this creates essentially two groups. You randomly assign people into what order they're going to get, and you can analyze for it, and then you can ignore it if there's no effects there. And so it's a great way to go. For two conditions, it's very easy to do because there's only two orders. Maybe you've got left condition, right condition. Condition L first, condition R second, and then other people get condition R first and condition L second. A study might be something like this, another which face is more attractive study, but hold on to your hats. This is not a pretty face to look at. These are the two faces you were looking at, L and R, left and right. The original is the one on the left, and the one on the right is the same guy, but his face has actually been made more symmetrical using Photoshop morphing technologies and such to adjust his face. It doesn't look very different, but actually there are meaningful differences between the two faces if you were to do a very careful analysis of them. And what we know is that typically people will see the face on the right as more attractive than the one on the left. Though with this guy, it's not, he's not a really good looking guy. We have to admit that. And so what you would have as a study is Jill getting the order left, right, and Nick getting the order right, left, and Francis getting the order right, left, and Orion, this was an old fraternity brother of mine, Orion, getting the order left, right. And the difference between their scores on the left and the right in terms of an attractiveness rating yields some representation of which is more attractive. And I'm proposing it would be the symmetrical face, but you may or may not disagree with that. When you get to three conditions, though, it gets tougher. By the way, the differences here are the left one and right one are the same as before, but the middle one is one that is symmetrical without there being any correction to fix the fact that the hairline is perfectly balanced and therefore actually kind of odd looking, and the facial blemishes have been removed, meaning that so it's kind of washed out his face in a lot of ways. Actually, he looks pretty good there. And so, but if you have three conditions, well, it gets into a lot more. For full counterbalancing, you have a lot more conditions you have to run. When there are three conditions, You have up to 6 total orders you have to run. Left, middle, right, left, right, middle, middle, left, right, middle, right, middle, left, right, left, middle. Bah. What about 4 conditions? 5. With 4 conditions, the number of orders goes up to 24. With 5 conditions, 120 different orders. So as you increase the number of conditions, complete counterbalancing becomes very impractical. With any reasonable number of participants, you can get into a study. Excuse me. Because of the fact that you may have more than just 3 conditions, you may have 4 and 5 conditions in your study, and you do want to try to deal with order effects to some extent, there are partial counterbalancing methods. Partial counterbalancing is used when there's a large number of conditions, and the goal is that any systematic effect of order is averaged out across the participants, so it's no longer a confound with the independent variable. You're just trying to have a good number of the possible orders presented, so there's no systematic, consistent ordering to the variables. There's 2 common ways to do it. Randomized partial counterbalancing simply means all the possible orders, if you have 5 conditions, 120 possible orders are available to select, and each person is randomly assigned to one of them. I've actually used that in a study once when I had a lot of orders I had to deal with, and I wanted to make sure that I got a good sampling of all the orders, because I knew I could never get all the orders represented. And then there's Latin square counterbalancing. Now, the good thing about this new book that I've picked here is it does not try to teach you how to do Latin square counterbalancing. I am so glad of that, because it's very confusing, and it's really not needed because we use computers to do this for us now. It's not that hard actually, but it is usually kind of confusing, and you'll never do it in real life as an undergraduate who's learning these things. The bottom line on Latin square counterbalancing is that each condition appears in each of the order locations, and participants are randomly assigned to the orders. And so if you have 5 orders, then or 5 conditions, then condition A will appear in the first position, the second condition, the third condition, the fourth condition, and the fifth condition at least once. And the same will happen with all of the other conditions in the study. External validity is obviously something we care about, but you may be surprised to know that we care about it less with experiments. And the reason we do is because experiments, we kind of recognize we're going to lose some external validity. It's because we're after something different. We are after control of extraneous variables, and that often moves us to a laboratory situation. This reduces what might be referred to as ecological validity, the application to real-world conditions, seeing these things happen in the real world. Laboratory conditions, however, don't stand alone. They must be compared to and integrated with field studies to clarify their meaning and their value. So how do we choose between within or between subjects designs? If conditions interfere with each other, meaning we have carryover for effects, it's really difficult to deal with carryover effects by any of the methods of counterbalancing that we were talking about. The bottom line is if you think you have carryover effects, you really need to go with a between subjects design. It's going to end up being better for you. Don't try to get there with some kind of balancing, because you won't get it done. If you have very few participants, or it's very costly to get them, within subjects designs are really going to be helpful for you because you gain a lot as long as you can get control of the various issues that we've been talking about here. If there's a lot of variability in how people respond to the stimuli, within subjects designs are usually better because you don't have to worry about that person-to-person variation being piled up all in one condition versus another, making it so that you can't really trust your data. Also, if doing all the conditions makes participation take a very long time and fatigue of being in the study gets to be a factor, you're going to end up having what we call mortality, participants dropping out of the study, which can sometimes be associated with the conditions of the study. then you want to go with a between subjects design if you can. You want to avoid having a within subjects design in that situation. In closing, experimental designs are our preferred method because we can make the strongest scientific claims that we want to make. We want to be able to make statements of causation between our manipulated variables and our dependent variables. Great care is needed in these designs to ensure that extraneous variables, particularly confounding variables, are eliminated to preserve the ability to make causal claims. Our strongest tool for eliminating the confound of selection, which is a particularly difficult one, is random assignment of participants to conditions. We can also manage this issue of a selection effect by having participants be their own controls, so to speak, by using within groups designs. Thank you for your attention to this, and I'll see you on the next presentation.